everybody. We're still solving parts of parallelograms here, and we're going to talk about properties and implications with parallelograms. In the previous video I didn't get to finish number 6, so I'm going to do that here. For number 6, remember our diagonals bisect each other in a parallelogram. So this side is y, and this side is 4. This angle is also 90. Opposite sides of a parallelogram are congruent, so that's 17 and that's x. Okay, and we're going to first work on x, and to solve for x we're going to use Pythagorean theorem by focusing on this big triangle right here. Notice it's a 90-degree triangle, a right triangle. We know across the way here 4 and 4 make 8, so one side's 8, that's a leg, x is an unknown leg, 17 is the hypotenuse. So we can go 8 squared plus x squared equals 17 squared. Okay, we know that 8 squared is 64, 17 squared is 289, and then here's x squared. So a little practice with Pythagorean theorem. Subtract 64 from both sides, this is 225. And the square root of 225 is 15. So now we have x. X is 15. This side and this side. Okay. Now, we are going to use another Pythagorean theorem. If we look at this triangle right here, it's sort of half of one of the triangles. It's a right triangle. One leg is 4, one leg is 15. We got to solve for y, which happens to be the hypotenuse. Y squared equals 4 squared plus 15 squared. Okay, and this is how we're going to solve for y. Okay, and then y squared is then equal to 16 plus 225. That comes out to 241. Okay, in order to solve for y, it's going to be the square root of 241 and approximately 15.5. And that's our y value, and here's our x value. Okay, now I'm just going to, instead of writing these out, I'm going to just read what the implications are. Complete each statement about parallelogram ABCD, justify your answer. For number 7, angle BAC, in the picture, we would see that is congruent to angle ACD. And the reason for that, if lines are parallel, then alternate interior angles are parallel. I'm sorry, let me say that again. If lines are parallel, then alternate interior angles are congruent. That's how we know angle BAC is congruent to angle ACD. Number 8, segment DE is congruent to BE. How do we know that? The diagonals of a parallelogram bisect each other. Number 9, triangle ADC is congruent to triangle CBA. How do we know that? The diagonals of a parallelogram divides the parallelogram into 2 congruent triangles. And then number 10, segment AD is parallel to segment CB. How do we know that? Opposite sides of a parallelogram are parallel. And there you go.